Hello class. Today we're going to be looking at a few more characteristics of our polynomial functions. We're going to look at where the zeros are and the multiplicity of those zeros, and combined with the other things that we've learned in the past about those characteristics of polynomial functions, we're going to be able to graph a sketch of those. So let's go ahead and get started. In our last unit, we were looking at quadratic functions, and we learned where those zeros were by a few different ways. We could either factor, sometimes we use the quadratic formula, or completing the square so that we could find those zeros and be able to graph the function more clearly. Now, this time we're going to be graphing things that are not quadrilaterals, but we're still going to refer to those skills. Now, this one's not a quadrilateral, but we can still factor that because it has a greatest common factor of x squared. X squared comes out and it's going to be x squared minus 4. Well, x squared minus 4 can be factored into x plus 2 and x minus 2. We still have that x squared there. Now, we're going to set each one of those factors equal 0. X squared equals 0. X plus 2 equals 0. And x minus 2 equals 0. So x squared divided by is equal to 0. The square root of x squared is x, and the square root of 0 is 0, whether it's positive or negative. And we're also going to have, when we subtract 2 from x plus 2 equals 0, we'll have x is equal to negative 2. And then when we add 2 to x minus 2, we'll have x also equal to 2. So our answer is x equals 0, negative 2, and 2. I have to wait for my pen to catch up. Do I have a 2 on there? All right, there we go. So in that last thing the last function that we factored, we had an x squared as one of the factors, and that gave us, when we set that to 0, x was a 0, but we had a multiplicity of 2, and we've never looked at that before. But the multiplicity refers to the number of times that factor occurs in the polynomial. So x occurs twice in the polynomial that we just did. Let's factor another one. Well, this one's already factored for us. We have two factors, x minus 1. We'll set that equal to 0. And then we also have x plus 3, which we'll set to 0. When we solve this, x minus 1 equals 0, we get x is equal to 1. And then we're going to state that it has a multiplicity of 2. I like to just go m2 because that's a long word. What that means then is that when it has an even one, it's going to be, or it occurs twice, and that means it's going to touch the graph and turn around. The x plus 3 gives us 0 of x equals negative 3, and that has a multiplicity of 3. Oops. Multiplicity of 3, which means it's going to cross the graph. But instead of just crossing straight up, that would be a multiplicity of 1. It's going to have a little curve to it to indicate that it's a little bit greater multiplicity than just 1. So I've already indicated on the previous slide what the odd and even multiplicities are going to mean. The odd multiplicities is going to cross the x-axis. And even ones, they're going to touch and turn. So something that's odd might go through like this. Something that's even, it's going to come down, touch it, and then bounce back. And as that multiplicity gets larger, it's going to flatten. So for example, if I wanted something like x to the 8th, it's going to come down, get real flat. There's only going to be one point that touches the graph, but it's going to look to the naked eye like several are. So as we're getting ready to